add fractions using fraction bars in Braining Camp. We're going to start with adding fractions with like denominators. So let's start with the fractions 3/10 plus 4/10. And the reason why I'm starting with like fractions is because it shows them that they need to add fractions with like denominators. We have to add fractions that have the same size, right? So 1, 2, 3/10, and then 4/10. 1, 2, 3, 4. Students can easily see that they are all broken up into the same size, in this case 1/10. So they can just add how many tenths do you have, and we have a total of 7/10. So let's look at adding fractions with unlike denominators. The biggest issue students have with unlike denominators is not creating those equivalent fractions. So we want to make sure that they understand when adding with unlike denominators, they need to create those equivalent fractions. So let's start with 2/5 plus 1/2. We're going to start building this. So we have 2/5. So 1, 2/5, and then 1/2. So right off the bat, students should realize that they can't add these two fractions together because they are not the same size. So what do we do about that? We have to create fractions that are equivalent to 2/5 and 1/2. And this is where that exploration piece is really going to come into play. They can explore different fractions. They can put pieces over the top of them and see if they work. So third won't work. Looking at sixes, how many would those work? Maybe eights. If they do, maybe put it underneath so they can see it. Nope, that's not going to work. So they can explore this way. There's also a feature in Braining Camp down here where it says basic called the wall. And this could really help a lot of students as well. If you go to the wall and we're looking for the fraction 2/5. So this helps us to move. So here's 2/5. Right here, here's 2/5. And then you line it up to show all the equivalent fractions. So right now we don't have any equivalent fractions here. We keep going. Oh, it lines up. It seems to line up with 4/10. So then we ask the kids, well, will tenths, or just that denominator of 10, work with 1/2 as well? So we move it to find the 1/2. So here's half right here. And then we look down to tenths and we see that it also falls on the line. So 1/2 is also 5/10. So that's our equivalent fractions. So we go back to the basic, we go back to the screen here, and we know we're going to be using tenths. So then we can just go ahead and put the tenths. We can easily see here that 2/5 is equivalent to 4/10. So I'm going to write that underneath. And then we also knew that we're going to use tenths for 1/2. So we just put these underneath and see how many fills the bar. 1, 2, 3, 4, 5. Again, I'm going to write it underneath. Now that we have equal pieces in order to add our fractions, we can add how many pieces we have. So we have 4 plus 5 more gives me 9/10. And here students can easily see that they need equal pieces in order to add fractions and those equivalent fractions. So let's try 2/3 plus 3/4. Again, we're going to approach this problem the same way. So we're going to build 2/3. So 1, 2, and then 3/4. 1, 2, 3. Hopefully they realize we can't add these fractions together because they are not the same size. So we need equivalent fractions. They can go through and kind of figure out how we can play with them here. We know sixes will work for thirds because it is a multiple, but will it work for fourths? Not quite. So the students can go through and play around this way if they wanted to. They can also use the wall. So if we go back to the wall, so we have 2/3. So I'm going to move it to 2/3. What's equivalent to 2/3? Not the fourths, fifths. Oh, sixes looks equivalent. So that's 4/6. Not the eighths or the 12th also. So 1, 2, 3, 4, 5, 6, 7, 8. 12th is also equivalent. So those are two denominators we can use. And let's see which one works for 3/4. So we go to fourths. We see that the 12ths are the only ones that work, because before we said it was the sixes, but the sixes won't work with the 3/4. So we have to use 12ths. So once they figure out what the denominator is, they can go back to the basic. They don't need to even know how many, because they just need to know the denominator, and we can figure it out from here. So now we're going to change them into 12ths. So 1, 2, 3, 4, 5, 6, 7, 8. So that we know that 2/3 is equal to 8/12. And then we're also going to use 12ths for 3/4. So let's see how many. 2, 3, 4, 5, 6, 7, 8, 9. So 3/4 is also equal to 9/12. Just like before, we're going to add how many 12ths do we have? We have a total of 17/12. Hopefully some kids will realize, hey, wait a minute, that's more than one, or we can't have a bigger number on top. So then now we talk about mixed numbers and how are we going to figure this out? We need to know how many 12ths will create one whole. So here's my one whole. And what we could do is just move these 12ths to the 1, and this will help the student try to figure out and understand that 12/12 equals one whole. So now we have 12/12 that equal one whole. So we have now one whole, and then how many 12ths left over? 1, 2, 3, 4, and 5. And eventually, once you do a couple more of these problems, they'll start realizing that they got the 5 by subtracting, which is what we do when we bottom out. And they also realize 12 is also a multiple of 3 and 4, so that's how they found the 12. So as they continue to do this, you're going to want to show them that algorithm and how we do this without using the manipulatives. So let's do one with mixed numbers. Let's look at the problem 1 and 5/6 plus 1 and 2/3. So we're going to start by building. So we have 1 and 5/6. So 1, 2, 3, 4, 5, and then 1 and 2/3. So 1 and 2. By looking at this, they can see that the ones are the same, so they can just add those. So that's not a big deal. 1 plus 1 is 2. The denominators and the fractions are the ones we have to worry about. So we have a denominator of 6 and a denominator of 3. So again, the kids can play around with the numbers. They can kind of figure out, which would work and do it that way. They can go to the wall and figure it out this way. So we have 5/6. So what matches with 5/6? Looks like the 12ths do. And then we also have 2/3. So we go to 2/3. What matches? Well, we have 6s and we have 12ths. Well, we already have 6s. So this is a good conversation to have with the kids about that least common denominator, where you can use 6, but you can also use 12. But 6 would be better as a denominator because it's smaller. So go back to the basic, and we're going to use 6s. This is already in a denominator of 6. So I'm going to move these over. I'm going to make these into the 6s. So now what do we have? We have 1 and 5/6 plus 1. And how many 6s? We have 1, 2, 3, 4, 6. So now we add across like we've done. So 1 plus 1 is 2. 5 plus 4 is 9 over 6. Again, hopefully the kids realize this fraction needs to be simplified. So how do we do that? We know we have at least one whole in here. So let's pull one whole. And now we can easily see we're going to have 3, right? So let's take these 6s. How many 6s equal one whole? Hopefully the kids should be able to tell you that. But maybe not yet. So how many 6s equal a whole? That's 6 6s. So we know now that we're going to have 3 wholes, 1, 2, 3, with 3 6s, 3 6 left over. And now we could talk about simplifying this fraction of 3 6. So we go back to the wall. We find 3 6 right here. Here's 3 6. And we look, well, it could equal 2/4, but can we do better? Yes, it equals 1/2. So we go back and we find that our final answer is 3 1/2. Hopefully this helps.